Hello, welcome. Let's try to solve another Leetcode problem, 147, Insertion Sort List. So for this problem, let's just check this drawing. Maybe it is helpful for us to understand what is the problem. Yeah, as we can see, so the insertion sort is just two for loops. Yeah, or we can say that it is just two loops. Yeah, so for each of the number, so for example, we find the number 4, we just need to find a place and to insert it. Yeah, let's just check this example. First, it is 6, it is okay. Now we're gonna loop through this 5. Yeah, because 5 is smaller, so what are we gonna do? We're gonna insert it to the right place. So 5 and 6, it is sorted. Now we find 3. So 3 is gonna compare with 6, it is smaller, and compare with 5, it is smaller, so we're gonna insert the 3 at this place. Now for this one, continually it will compare with all the values from the right to the left until it can never find a number which is bigger, so we just insert it. If it is bigger, for this 6, it is just there. For the 7, it is just find a number, it is smaller, but this 7 is going to be bigger than this 6, so we're going to insert it. And similarly for this 2, and for that number 4. But for our problem, it is a linked list. We cannot directly use the method like the insertion sort in an array. Yeah, so the idea for the linked list is that we are still going to find the node. So for example, the first node is 4, it is okay. Now we find a node which is 2. Yeah, and we know that this node 2, the value 2 is smaller than 4. So this means we're gonna insert the 2 to the previous node. So currently it is 4, and we have a node 2. Yeah, but this node 2 cannot be here. So this node 2 must be this place. Yeah, so this means why we find a number. So for example, the value of this node, it is smaller than the previous value. What are we gonna do? We cannot compare like from the right to the left because this is a singly linked list. So we have to start from the beginning. So we're going to prepare a dummy node. So this dummy node is going to be ported to this node 4. Yeah. So if we find a value, yeah. So if we find a value, we're going to compare like this. So this is going to be the previous value. Yeah, and this is going to be the current pointer. So we're going to always compare two values, the previous with the current. So if the current node value, which is 2, it is smaller than the previous value, so that means there's going to be an insertion. But how can we start? We cannot start from the right to the left. We have to start from the beginning. So we're going to start from the dummy node. It's going to be start from the dummy node next. So this node 2 is going to compare with node 4. So if it is smaller, so we're going to insert it. So this is a dummy node, and this is node 4, but after insertion, this is going to be node 2. So currently, I'm not talking about how to insert, but the idea is the node 2 will be here, and the node 4 will be here. Yeah, and then we're gonna have a node. We're gonna have a node 1 and a node 3 after that. Yeah. So for the next step is that we're going to check this node 1. So why we find this node 1, this is the current node, and this is the previous node. And this is the, I'm going to define a pointer, maybe P, and this is the previous. So the P is going to be ported to the dummy node. And this is just the current node. So if we find a current node which is 1, so 1 going to compare with the previous node. So if it is smaller, so that means there's going to be an insertion, right? So the insertion is going to be starting from the P dot next. It's going to be starting from 2. So 1 going to compare with 2. So 1 is smaller, so that means 1 going to be inserted here. Yeah. So the dummy node going to port it to 1, 1 going to port it to 2, and 2 going to port it to 4. Yeah, and this 4 going to be ported to 3. Yeah, as you can see, it is not so easy why we are doing such kind of operation. I mean, we must be really familiar with the insertion. You know, for the iteration for the linked list, it is easy, or deletion, it is easy, but for the insertion, actually, it is not so easy. Normally, we're going to prepare a dummy node. But exactly what going to be the insertion? Let's just check that. Let's just check this example. Let me just go back. So currently we have a node which is 1. Now we want to insert this node 1 in between the dummy node and the node 2, because in this way it's going to be the dummy node pointed to 1, 2, 4, and 3. And next we're going to insert that node 3. But currently, how can we insert this node 1? Yeah, so this is the current node, and this is the previous node. So what is going to be the first step? So the first step is because we're going to use this node 3. So the previous dot next going to equal to the previous dot next going to equal to this node is current dot next. Yeah, let me maybe just write something here. Yeah, so there are going to be some steps. So the first step is prev dot next is going to be equal to current dot next. So in this way, the prev dot next is going to equal to current dot next. This means here I'm going to delete this pass, and this node 4 going to be pointed to node 3. So this is going to be the first step. So what is the next? I cannot write. Yeah, so this is currently this previous node pointed to this node 3. This is going to be the first step. Yeah. So what about this current node? So this is node 1. So the current node, currently it is pointed to node 3, but this node 1 should pointed to this node 2. But how can this node 1 pointed to node 2? This means the current dot next should equal to this pointer p dot next. So this is p dot next. So current dot next gonna equal to p dot next. Yeah, let me make a drawing. So this is my current. So current gonna not be pointed to 3, but current dot next. This is current dot next gonna equal to p dot next. So this node 1 gonna be pointed to node 2. Yeah. So this means here will be here is still connected. Yeah. So this current dot next gonna be pointed to p dot next. This means node 1 gonna be pointed to node 2. Yeah. But which node should be pointed to the current? So the p dot next gonna be pointed to the current. So I will disconnect it, and p dot next would, let me use this way, gonna be connected to the current. Yeah. Let me just remove here, make it better. Yeah. So this is p dot next gonna be pointed to the current. So in this way, this is my pointer p. P gonna be pointed to node 1, node 2, node 4, and node 3. So this is exactly what we did. But after that, we need to get the current. We needed to update the current. Currently, the current pointed to node 1, but finally, the current gonna be pointed to node 3 because we needed to discover a new node. Yeah. So finally, the current gonna equal to prev.next. Yeah. So let me just finish the writing. So the p dot next gonna equal to the current. So here, the p dot next gonna equal to the current, and current gonna equal to prev.next. So this is just from the drawing, according to how we design the previous node and current node and the p node. P node will always be beginning from the dummy node because I want to check which value gonna be, which value gonna be smaller than my current value. For example, this is node 1. I'm gonna check which value is exactly bigger than this node 1. So this node 2 is bigger than node 1. Then I'm gonna start the insertion. Yeah. Otherwise, if node value is bigger, so I'm gonna loop through it until I find a value which is bigger than my current node value. Yeah. So 2 is bigger, so I'm gonna insert here. So for this node 3, normally I'm gonna, after finish, it will be dummy node 1, 2. For this node 3, I'm gonna insert it between 2 and 4 because 4 is bigger than 3, so I'm sure I'm gonna insert here. Yeah. So let me make a comment of this insertion calculation. Let's just start from the beginning. Yeah. So we're gonna prepare a dummy node, as I said before, it's gonna be a list node. So the node.next gonna equal to the head. It's gonna be ported to the head. Now we're gonna prepare a prev and current. So the prev gonna equal to the head and current equal to head dot next, because we always want to compare two nodes to check their values. Yeah. So if the current node value is bigger than the previous node value, so everything's okay. Yeah. So we're gonna check the current. So if current dot value is let's say, so the result gonna be non-decreasing, I think. We just make it to be sorted. Yeah, we just need to sort it. Yeah. So if current dot value is more than and equal to previous dot value, so everything should be okay. Yeah. So we just need to update the prev and the current gonna equal to the current and the current dot next. We just need to update it, and we're gonna continue. Yeah. So if everything's okay, we just need to update and continue to check the current. So for example, this case is for example like 1 2 3. So this is my 1 2 3. This is my previous, and this is the current. So if current value is more than or equal, so I'm just update the previous, update the current. So if current value is more than or equal to the previous dot value, so the current gonna be updated here, and this gonna be my previous. Currently current ported to none, so I just need to return dummy.next. Yeah, so this is for this kind of checking. Yeah, because finally I want to return dummy.next. Yeah, but if current dot value is less than previous dot value, so this means we need an insertion. So we're gonna prepare a pointer p. It's gonna be ported to the dummy node. Now I'm going to, yeah, so currently I'm going to prepare this pointer p. It's going to be equal to the dummy node, and then I'm going to finish the insertions. So the insertions will be this kind of 4 lines. Yeah, so this is my pointer p, and this is a current, it is 1, and this is a previous, it is 4. So I will finish this kind of insertion. So how many steps? It's going to be 4 steps. So first of all, the prev.next going to equal to current.next. So this is a prev.next, current.next, 4 going to be ported to 3, and current.next, this is current.next, it's going to be ported to 2, it's going to be equal to p.next. Yeah, and p.next going to equal to the current. So this is a p.next going to equal to current, and current is going to update it to previous.next. It's going to be exactly those 4 lines, and we're going to finish the insertion to the right place. So for example, this node 1 will be inserted between the dummy node and 2. So let me just copy on those 4 lines of code just to finish the insertion from here. Yeah. Now we finish the insertion, and everything should be okay. Finally, we just need to return dummy.next. Yeah, I think it should be like this, but let me just run it. Something's wrong. Oh, I think I need to check the values. While I am preparing this node p, I need to check the values, I think. So while, yeah, because this is not just one operation, I need to check. I need to find the place to check. So while I'm preparing the p equal to the dummy node, so I'm gonna check the values while current. Yeah, so while current dot value. Yeah, let me go back. So while current dot value, because this is not my place, I need to check where it is. So while the current dot value is less than the previous dot next dot value. Yeah, but if it is more than that, I just need to check for the next. Yeah. So if current dot value, while current dot value is more than p dot next dot value. So I'm gonna update the p gonna equal to p.next. Yeah, so this is because currently this is not 1. So for example, before maybe there's a not 0. So if this value 1 is more than p.next.value, more than this 0, so I'm gonna update the pointer p. So p gonna equal to p.next. So p gonna be here. So for the next place, this is 0. I'm gonna insert 1 between 0 and 2. Yeah, so I need to check from the beginning from this pointer p. So p gonna equal to p.next. And then if I go out of the while loop, it means I've already found the insertion place and just need to insert it. Now let me just run it. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it's pretty fast. And definitely, this problem is not an easy problem. I mean, for the array insertion sort, definitely it's not difficult, but this is a linked list, and everything we must be designed correctly. And we have to simulate the insertion by using a linked list. And for the insertion, especially about these areas, we need to find how to insert a node. Definitely, we need to practice a lot, and we need to familiar with what kind of linked list insertion, and then we can solve such kind of problem. So I have to say, for solving such kind of problem, you have to practice a little bit about linked list insertion. Yeah, you know, if you didn't practice for a long time, you might forget about what is the steps. Yeah, because those kind of operations is not so easy to write. I think that